Good morning, all. This is Arnie Hackett in Raleigh. This is the second quarter of education session. Today we're going to present the ComServer R13 overview. We have Mr. Scott Moonen, who is the release chief programmer. And with that, I'll turn it over to Scott.
Thanks, Arnie. As Arnie mentioned, my name is Scott Moonen. I was chief programmer for V1R13. This presentation that we're going through today is based largely on one that Alfred Christensen has given at Share and other places. I apologize today you don't get to enjoy the lovely sound of Alfred's Danish accent. You'll have to put up with my voice. By way of introduction, just a reminder that as with everything that hasn't been released yet, these statements that we're going to make in this presentation are subject to change. But as you can see, our planned GA date is September of this year, so there's not a lot of runway to change anything at this point. So we expect this to remain largely unchanged. The first thing I'll talk about is some of the themes that have guided our selection of content for V1R13. The first theme you see on this page is the continued evolution of System Z technology, and this refers to technologies such as the Enterprise, ZBX. So some of the line items we have address requirements related to this evolving technology. Skills, mainframe skills is also an issue that drives requirements and has guided our choice of line items for this release. So one of the themes that we try to focus on in consumability and usability. And a lot of those items relate specifically to the IBM Configuration Assistant, ease of configuration. So security is another theme that drives our focus and has influenced the choice of line items in this release. Performance is another of the themes that has influenced the selection of items in V1R13. We continue to try to improve performance of z/OS networking. Autonomic integration capabilities, and this refers largely to integration with the ZBX, the ability to integrate with other platforms and other technologies seamlessly. And finally, the increasing move to IPv6 as the IPv4 address space is exhausted. So we have some line items that pertain to IPv6. The first theme we'll talk about is security. Before talking about intrusion detection services, I'll give you a little bit of an overview of our intrusion detection services, or IDS function. Your IDS policy might be configured using the IBM Configuration Assistant. The policy itself is read by the z/OS policy agent and installed in the TCP/IP stack. The stack then performs monitoring activities, trying to detect attacks and floods and other events. And then based on your policy, what you've configured in your policy, the stack might, for example, notify you by various means of events or attacks that occur. This could include messages that are logged to syslogd, messages logged to the system console, or packets that are traced to the IDS trace. Then the stack could take additional actions, defensive actions, to, for example, drop packets, reset connections, depending on the type of attack that's been detected. And finally, other applications or network management tools can consume the logging information that has been produced as a result of the stack detecting and logging these events. So some examples of that would be the TRMD stat tool, which post-processes your Unix syslog to summarize the attacks that have been detected, or the Tivoli Security Operations Manager, formerly called TSOM. I think it's been renamed TSIEM. I can't remember offhand what that acronym stands for. The important thing to note on this page is that the current IDS support prior to V1R13 only included support for IPv4 traffic. So we'll see on the next page that what we've done in V1R13 is add IDS support for IPv6 traffic. So we've extended the IPv4 attack types to include support for IPv6. This includes scan detection. It includes traffic regulation for TCP and UDP. It includes all the appropriate attack types that were detected for IPv4 formerly. They're now extended to IPv6. And it also includes flood attacks, such as the TCP SYN flood. We've also added a few new attacks that are specific to IPv6 because of the unique way in which the IPv6 header is constructed as opposed to the IPv4 header. So there are three attacks, or rather configuration options you have that are specific to IPv6. You can restrict IPv6 next header values, you can restrict IPv6 hop options, and you can restrict IPv6 destination options. One thing that's important to note is that the Defense Manager daemon is not, while it's not directly a part of our IDS support, it is related to our IDS support in that you could automate on IDS messages and use the Defense Manager to install dynamic defensive filters to deflect attacks. The Defense Manager daemon already supported IPv6, so what's being enhanced in this release is IDS itself, not the Defense Manager daemon. That already supported IPv6. We've also added some new attacks for both IPv4 and IPv6. Those are listed on this page. The global TCP stall attack detects when a large number of TCP connections are in a stalled state, unable to send data. The actions that you can take for this attack are to log the event and optionally to reset these TCP connections. There's a new data hiding attack that detects the use of reserved fields as a covert channel to send data without detection. That applies to both IPv4 and IPv6. And there's a new TCP queue size attack that detects cases where TCP queues are filled with a large amount of data, such as send, receive, or out-of-order queues. If those queues remain filled for a certain period of time, we will always move that data to pageable storage as a defensive action, and then optionally we can log the event and reset the TCP connections based on your IDS policy configuration. Another item in our security theme is support for network address translation using IKV2. In V1R7 and V1R8, we introduced support for network address translation with IPsec and IKE. In V1R12, we introduced support for the IKV2 protocol, the next generation of the IKE protocol. However, that support did not include the ability to traverse NAT devices when using IKV2. So beginning in V1R13, we've added support for traversing NAT devices when you're using IKV2 and IPsec. And all of the topologies that we supported in IKV1 NAT traversal are supported in IKV2 NAT traversal. So that includes robust and thorough support for NAT traversal when ZOS is acting as a responder or server. And it includes a good amount of support wherever possible when ZOS is acting as a client. Also in the security theme, we've added support for password phrases to a couple of our servers. By way of review, a password can be 1 to 8 characters, and a limited range of characters are allowed. For example, you can't have a space in a password. RACF and potentially other security products allow password phrases, which can range from 9 to 100 characters, and a password phrase can include a broader variety of characters, including, for example, spaces. It's important to note that a user ID has both a password and a password phrase, so a user could log in using either of those. The password phrase is designed to be more memorable, so it's equally secure as a password that uses a combination of many different numbers and letters and symbols. So every user ID that has a password also has a password phrase. And what we've done in V1R13 is add support for password phrases to our FTP server, to our FTP client, and to our TN3270 server. The support in the TN3270 server is only for the solicitor screen. You may or may not be using the solicitor screen. Your applications will have their own login screen, and those would need to have their own changes made to add support for password phrases. For example, TSO has a configuration option that allows you to have your TSO users log in using password phrases. So that would be independent of the TN3270 server's solicitor screen, which now also supports password phrases. Another item in our security theme is security for binding to dynamic VIPAs, enhanced security granularity. The VIPA range statement allows you to define a range of dynamic VIPAs that can be activated by applications. And an application can activate one of these VIPAs either by binding a socket to that IP address or by issuing an ioctl, the mod devipa ioctl. The SIOCS VIPA ioctl, I think is what it is. The mod devipa tool issues that ioctl in order to create one of these application-specific VIPAs. Prior to V1R13, we've had a level of security for these dynamic VIPAs, for the creation of these dynamic VIPAs. However, it was one single global SAF profile that allowed access to all or none of these VIPAs. This access wasn't granular enough to allow an application to start one VIPA but not start another, so it presents the possibility that an application could intrude on another application's VIPAs. So what we've done in V1R13 is add a new parameter to the VIPA range statement, the SAF parameter, and that allows you to define a keyword. In the example on this page, it's Apple1, that is used as part of a more granular SAF check for permission to activate a VIPA. So if you use this keyword, the more granular profile name that's shown on this slide will be used to check for authorized access. If you don't specify the staff profile, the authorization behavior is as it was formerly. It uses the more generic form of the resource name. Next theme we'll talk about is simplification. Background information, the IBM Configuration Assistant for ZOS Communications Server has been available for a number of releases. It's available in two forms. One form is integrated into the ZOSMF tool. Version of the Configuration Assistant is officially supported. There's also a standalone Windows GUI that you can download, but this version of the Configuration Assistant is available as is. It's not officially supported. The first simplification item that we'll discuss has to do with support for multiple releases in the Configuration Assistant. ZOSMF, by design, is intended to be used with only one instance of ZOSMF running in the sysplex. And if you have multiple release levels in your sysplex, there's a need to be able to configure multiple TCP/IP release levels using the Configuration Assistant. So beginning in V1R13, we are supporting the configuration of multiple release levels using the Configuration Assistant. So your ZOS image configured within the Configuration Assistant will now have a designated release level. And in V1R13, you'll be able to set that designated release level to V1R12 or V1R13. And the Configuration Assistant will generate a policy that's appropriate to that release level. And you'll begin to see in some of the Configuration Assistant screens and panels that some of the options that you can choose are available only in V1R13. For example, the new IDS support that we discussed earlier. Our intention is to support ultimately all currently supported release levels in the Configuration Assistant. So we would hope that in the next release, you would be able to configure ZOS V1R12, ZOS V1R13, and ZOS V1R14. Another feature that we've added to the Configuration Assistant in V1R13 is easier support for managing multiple stacks. What you can do now is we've added a new type of reusable object. Formerly we had reusable objects such as security levels and requirement maps. New reusable object is a reusable connectivity rule. So now you can define a connectivity rule that's a reusable rule, and you can add this reusable connectivity rule to multiple stacks. Whenever you make a change to this reusable rule, the change is immediately reflected in all the stacks that have added that rule. Example of a way that you might want to use this support if you have a distributed dynamic VIPA. Create one single reusable connectivity rule to pertain to the traffic for this distributed VIPA, and then you can add this rule to the distributor stack, to the backup stacks, and to all of the target stacks. And immediately, any change that you make to that rule as you manage or to VIPA will be reflected in all of those stacks. Another thing that we've done in these reusable rules, and actually in any of your connectivity rules, is add support for some named symbols that can be filled in with stack-specific information. The two symbols we're supporting in V1R13 are local IP addresses and local IC identities for your IPsec negotiations. You can define a reusable connectivity rule, and actually I'll go to the next page. We can see an example of that. So the first rule that you see listed has a name EE-VIPA. And if you can imagine, we've created a connectivity rule, and instead of specifying a local IP address for this connectivity rule, we've actually put in the name EE-VIPA as a substitutable name for each individual TCP/IP stack. So then this connectivity rule has been installed on ZOS1 and ZOS2 images, and on each of those images, the name EE-VIPA, the local IP address name EE-VIPA, has been substituted with a different IP address. See, the same happens with OSA primary and OSA secondary on the other two connectivity rules on this slide. Those named symbols, those named local IP addresses, are substituted with different IP addresses on each individual stack. So this allows you to define a reusable connectivity rule that can be added to multiple stacks, and each stack substitutes IP addresses that are specific to that stack. And the same is true of IC identities. You can substitute identity that's appropriate to a given TCP/IP stack. Finally, we've also introduced support in the Configuration Assistant to query the TCP/IP stack for configuration information. What this allows you to do is connect from the Configuration Assistant to the TCP/IP stack and determine all of the configured IP addresses, including interfaces, device link statements, as well as your DeVIPAs. Pull that information into the Configuration Assistant. That will predefine these local IP address symbols that you saw on the previous page so that you can immediately start using them in your reusable connectivity rules. So again, the support that we have is for Configuration Assistant to connect to TCP/IP to discover the IP address and interface names or devices, import that information into the Configuration Assistant for use in these named symbols that you can now configure in your connectivity rules. This support is only available in the ZOSMF version of the Configuration Assistant, not in the Windows GUI. The next theme we'll talk about is economics and platform efficiency. One of the changes we've made in this release in V1R13 is to support more than 8 VLANs. So to review, in V1R10 we added support for multiple VLANs. You can configure multiple interface statements to the same OSA with different VLAN IDs. And since V1R10, we've supported up to 8 IPv4 and 8 IPv6 VLANs per OSA. In V1R13, we're raising that limit from 8 to 32, so you can now configure up to 32 IPv4 and 32 IPv6 VLANs. No OSA changes or upgrades are needed for this support. It's a ComServer-specific, ComServer-only change. And one of the driving factors that influenced us to make this change is the growth in use of the ZBX environment and the need for increased partitioning of the intra-ensemble data network into multiple VLANs to support ZBX usage. Another change we've made in V1R13 is to have additional exploitation of 64-bit. We've moved a number of traces from where they're located today to 64-bit common storage. We've moved the VIT trace from ECSA and from data space to 64-bit common storage. And we've moved multiple C-trace components from data space storage, where they exist today, to 64-bit common storage. In one case, we've moved a C-trace component to 64-bit private storage. That's the TN3270E C-trace. But all the other C-traces that are listed as having changed on this slide, you can see have moved to 64-bit common storage. And on the next slide, we just see a diagram, definitely not shown to scale, of the ZOS virtual storage. The location of the new traces, the new location of the VIT and the various C-traces, is the default shared memory addressing region that you see next to the very topmost region on this diagram. And finally, we've also made some miscellaneous performance improvements. We have the goal each release of trying to achieve a 5% internal throughput rate improvement in our throughput from release to release. And we believe that we will be able to make this goal in V1R13, a 5% throughput improvement. Some examples of the things that we've done to achieve this result would include increased use of compiler optimization, would also include taking better advantage of the Z architecture cache lines in the way that we structure our data. We've also made a change to the TN3270 server so that when it receives a large amount of data, it receives that in fewer sends than fewer receive operations than it used to. The next thing we'll talk about is availability. In V1R12, we introduced support for the ZOS system resolver to detect when a name server becomes unresponsive. So the resolver would monitor your name servers, and when a name server was determined to be unresponsive, it could log a message to the system console so the operator could take an action. In V1R13, we've enhanced this function. You can optionally configure this function, this monitoring function, to take the action of no longer using a name server that's been deemed to be unresponsive. So now, beginning in V1R13, when a name server becomes unresponsive, you can optionally cause the system resolver to stop using that name server. While we're not using it, the system resolver will continue to poll that name server periodically to discover when it becomes responsive again. And once it is deemed responsive again, it will be reintroduced into the list of eligible name servers. We've enhanced the CSSMTP daemon. Previously, the CSSMTP daemon could retry an email message for up to 5 days if the message was then unable to be delivered before the message was deemed permanently undeliverable. However, while it was retrying this message, neither the JES spool resources nor the CSSMTP in-memory resources were freed. So if you had a large number of undeliverable mail that was being retried, it could consume a decent amount of system resources. What we've introduced in V1R13 is an extended retry function for CSSMTP server. When you configure extended retry, after the initial retry period is complete, what we'll do is we'll free the JES spool file, and we'll free the in-memory storage in CSSMTP and write the undeliverable mail to disk. Then periodically we'll continue to retry that email, sending that email, until the configured limit that you've established for extended retry. At that point, then, the message would be deemed permanently undeliverable if we weren't able to deliver it during that interval. So again, the main advantage here is that you can have a longer period of retry, and the JES spool resources and in-memory resources are released during this time period. We've also expanded the number of code pages that are supported by CSSMTP for translation. Previously, there were a limited number of code pages that were supported, but now a broader number of code pages are supported, and in fact, you can also code a user-defined code page in Unicode services and use that for your CSSMTP translation, provided that there's a round-trip translation between your code page and ASCII and back, and a round-trip translation between your code page and IBM 1047 EBCDIC and back. So provided that those conditions hold, you can define your own user-specific code page in ZOS Unicode services and use that now using CSSMTP. When the TCP/IP stack first joins or rejoins the sysplex, or when OMP route is recycled, there can be a brief interval of time between that event and when OMP route actually discovers and updates the TCP/IP routes. The Viper route function caches the routes that it knows to each target stack. And the initial cache is established when TCP/IP first joins or rejoins, and is later updated at some point after the OMP routes are updated in the TCP/IP stack. The time interval for this update was formerly, prior to V1R13, was every 60 seconds, which could result in a significant delay of reestablishment of connectivity when the TCP/IP stack rejoins the sysplex. So what we've done starting in V1R13 is to reduce that time interval during the initial period of time when TCP/IP joins or rejoins, or the initial period of time after OMP route is restarted, so that the Viper route target cache is updated more promptly and your traffic is able to be reestablished more quickly. We've also enhanced Sysplex Autonomics in V1R13. Sysplex Autonomics monitors the health of various components of the Sysplex distribution function. So that includes the TCP/IP stack, its storage utilization, the interfaces, VTAM itself, VTAM's connection to the coupling facility's own health. And when any of these conditions become a problem for Sysplex distributor, the Sysplex Autonomics function can optionally notify the operator. It could cause TCP/IP to leave the Sysplex group, and optionally cause TCP/IP to rejoin the Sysplex group once the condition is no longer a problem. Prior to V1R13, Sysplex Autonomics has monitored for when CSM storage reaches a critical level. However, CSM storage can also present a problem when it reaches a constrained level. There can be some operations, some Sysplex-related operations that aren't able to complete when CSM storage is at a constrained level. So beginning in V1R13, we're now also monitoring, Sysplex Autonomics is now also monitoring for when CSM storage reaches a constrained level. If it has reached and maintained a constrained level for 3 of the timer seconds monitoring periods, then the stack will take action based on your Sysplex Autonomics configuration, potentially leaving the Sysplex group. And this is also an event that is eligible for rejoining the Sysplex group once the CSM storage is reduced to a level below the constrained state. Sysplex-wide security associations is a function that allows Sysplex distributor to coexist with IPsec. There's 2 components to Sysplex-wide security associations, or what we call SWASA. One component allows takeover of a DEVIPA, so that when a DEVIPA is taken over, the IPsec security association or tunnel is also taken over by the backup stack. So the backup stack has enough information to renegotiate whatever tunnels were owned on the primary stack. The takeover is one component of SWASA. The other component of SWASA has to do with distribution. Distribution of IPsec tunnels and therefore TCP traffic through those tunnels from the distributor to the target stacks. So SWASA allows for both the backup, takeover, and also the distribution of IPsec tunnels in coordination with Sysplex distributor and dynamic VIPAs. In V1R12, we introduced support for IKV2, as I mentioned earlier. However, that support did not extend to SWASA, so IKV2 tunnels could not be distributed or were not eligible for takeover by a backup stack. Beginning in V1R13, we've extended our IKV2 support to now allow for SWASA. So both of these functions, takeover and also distribution, are now eligible for IKV2 security associations or IKV2 tunnels if you've enabled SWASA in your TCP/IP profile. As a reminder, the SWASA function remains an IPv4 only function. It's a known requirement. We have a known requirement to support IPsec for IPv6 devices. The next theme we'll talk about is application, middleware, and workload enablement. First, we'll talk a little bit about FTP. Beginning in V1R11, FTP has had a toleration mode support for extended address volumes. Extended address volumes, as you can see by the diagram, have a much greater capacity. And in particular, there's a part of the volume, the extended addressing space, or EAS, where only certain eligible data sets are able to reside in this portion of the extended address volume. So we call them EAS eligible data sets. So FTP support has been a toleration mode only since V1R11. It's supported reading and writing existing EAS eligible data sets. And it's also supported creating them, but only indirectly through the use of an SMS data class that had specified EAS eligibility as one of its options. Beginning in V1R13, FTP has full support now for extended address volumes and EAS eligible data sets. There are now configuration options and FTP subcommands that you can issue to explicitly create data sets that are EAS eligible. In V1R13, FTP has also been extended to support large format data sets. So we can now, there's now in V1R13 some explicit configuration options and FTP subcommands that allow you to explicitly create large format data sets. And as you see on the diagram, the large format data set can potentially have a much greater number of tracks per volume. However, it doesn't necessarily have to be a large data set. So hence we use the terminology large format data set, say that it's capable of being large, although it might actually be as small as one track. Additionally, in V1R13, we've also added support to FTP for reading and writing ZOS Unix files that are more than 2 gigabytes in size. We've added a new display command in V1R13 to display the list of TN3270 servers. You may be familiar with the DTCP/IP command that shows the list of TCP/IP stacks. The new DTCP/IP, telnet command displays the list of TN3270 servers. You might be used to seeing a job name in the second position on this command where the word telnet now appears. This command is a special case. Since there's no comma after the telnet, it's not treated as a job name. So the actual command is DTCP/IP, telnet, regardless of the name or the job name of your telnet server. The command always uses the keyword telnet. And be sure not to put a trailing comma on that, otherwise it would be interpreted as a job name. We've introduced in V1R13 a new network management interface that allows you to retrieve the system resolver configuration. This is a callable network management interface. It kind of follows the model and structure of the TCP/IP callable network management interface. The name of this call is EZB-REIFR. It supports one request type called getResolverConfig. And this retrieves both the contents of the resolver configuration file, and if you have a global TCP/IP data file, it retrieves the contents of the global TCP/IP data file. We've also made an enhancement to another network management interface, the real-time network monitoring interface. There's a function that's part of this interface called the TMI copy buffer function. Prior to V1R13, the TMI copy buffer function has required the caller to be APF authorized. Beginning in V1R13, if a caller is not APF authorized, we make an additional check to see if the caller is authorized to the SAF profile that's listed on this page. The profile name varies depending on which interface you're trying to copy data for. And this is the same profile that's used when you make the initial connection request to connect to the interface. Beginning in V1R13, you don't have to be APF authorized. As an alternative to being APF authorized, we allow your application to be permitted to this profile. In V1R13, we've enhanced the port range statement. Since V1R5, we've supported partial wildcarding of job names on the port statement. So, for example, you could use a job name of FTP asterisk, which would match any job whose name started with the letters FTP. We've extended this wildcarding support to the port range statement in this release, and so now you can specify a partially wildcarded job name on the port range statement. So again, for example, if you use a job name of FTP asterisk, it will match any job whose name starts with the letters FTP. Next on our agenda, we'll talk about the line items related to EE and SNA. The display EE diag, test equals yes command is sort of a combination ping and trace route for EE. It allows you to discover both the round trip time between you and a partner to perform a reachability test, discover the round trip time, and it also discovers, wherever possible, the hop count between you and a partner. So it does this in the same way that the TCP/IP traceroute function works. It sends a UDP message with a hop limit of 1. It should get back an ICMP hop limit exceeded message. It sends a UDP message then next with a hop limit of 2 and gets another ICMP error until it reaches the final destination. Potential problem with this is that in some network environments, firewalls actually block these ICMP errors, and that can cause the display EE diag command to take a long time to complete because first it will time out each packet that it's sent, waiting for the ICMP error, and then it will try each of those 3 times before it moves on to the next hop limit. So it could take, depending on the number of hops between you and your partner, your connection partner, potentially a long time for this command to complete. So what we've done in V1R13 is modify the list equals summary form of this command to do a quick form of the test. Instead of varying the hop limit from 1 hop and 2 hops, we'll immediately set the hop limit to the maximum TTL value, send it out. We should get an immediate response from the connection partner to verify connection reachability. Because of this, you'll be able to use this form of the command to determine reachability and to determine round trip time, but you won't be able to use it to determine the number of hops between you and your partner. So as you'll see on this sample screen, the asterisk NA reflects that the hop count is unknown when you use this form of the command. If you're interested in determining the hop limit and you're willing to wait a while if there's a potential firewall blocking ICMP messages, you can still use the list equals detail form of the command, which uses the old behavior. That will determine the hop limit wherever possible. Earlier, we talked about some IDS enhancements for IPv6. We've also made in V1R13 some IDS enhancements for Enterprise Extender. So as you see the diagram of an Enterprise Extender packet down here on the bottom of this slide, the existing IDS checks and attack detection applies to the IP header and the UDP header. But the new EE-specific IDS support that we've added applies largely to the EE headers that follow the UDP header in the EE packet. So there are 4 attack types listed on this slide that we've added in V1R13. The malformed packet check checks the EE headers to see that they're well formed. The EE LDLC check checks that certain LDLC commands arrive on the expected port and not on an unexpected EE port. The EE port check is a more generic port checking attack type that verifies that the source port for an EE message is equal to the destination port and is in the expected range, which if you've left your configuration as default would be ports 12,000 through 12,004. Finally, the EE XID flood attack type detects cases where there's a flood of XIDs. You can, exclusion lists are available for each of these attack types that allow you to define a certain remote partner as being excluded from this checking. If, for example, you know that a certain remote host misuses the EE ports and you don't want it to be detected as an attack, you don't want its packets to be discarded, you can exclude that host from checking. The allowable actions that you can configure for these attacks are to discard the packets or to simply notify the operator either through console messages or syslog-d messages. And the IBM Configuration Assistant has been enhanced to support configuration of these new EE attack types. Finally, all of these EE attack types, our support for checking for them extends to both IPv4 and IPv6. And on the next slide, you can see an example of a Configuration Assistant panel with all 4 of these EE attack types enabled. There have been some cases in which APPN routes within VTAM have been corrupted, and under these rare circumstances, there's a potential for VTAM to experience recursive abends that would require VTAM itself to be restarted as the only course of action. So what we've done to defend against these rare occasions is add new support to the APPN routing function to detect when these recursive abends are occurring, when an abend has occurred while doing a route lookup. And when that occurs, what we'll do is immediately free all of the APPN routing information. The routing tree will be dynamically rebuilt by VTAM as needed, and this should alleviate the condition that would have caused the recursive abends. And so no longer would you need to restart VTAM if this rare condition occurs. There's also a new operator command that allows you to manually free all of the APPN routing information, the APPN routing tree, but we recommend that you only use this command if directed to do so by IBM service. The last thing we'll look at is a statement of direction and some reference material. By now, I hope that you're familiar with the statement of direction, but ZOS V1R13 is planned to be the last release in which the bind 9.2.0 function is available. There are several migration actions that you can take to accommodate the statement of direction. First of all, if you're using bind only to cache, only as a caching name server, since V1R11, the system resolver has supported caching. So as an alternative to using bind for caching, you can enable caching in your system resolver and no longer need to use DNS bind for that function. If you're actually using DNS bind as a primary or secondary authoritative name server, there's a couple of options for you in that case. First of all, you could use an IBM Z-Linux image on the mainframe to serve as your name server. Second of all, you could use an IBM Blade to serve as your name server. Finally, we have a lot of reference material on this last slide. As a reminder, we have a Twitter account and a Facebook account. We periodically post articles, videos that are relevant to IBM Communications Server. There's also a number of other links here to communications server information as well as more general networking information.
Thank you, Scott. I'd like to thank all of you for attending, and with that, I'll end the session. Thank you. Take care.